So to finish up plate tectonics, we have two more types of tectonic plate boundaries to discuss. That is convergent and transform boundaries. So transform is pretty easy and straightforward. I only have a couple slides for that. Convergent we'll elaborate a little bit more on in a minute. So just to remind you, tectonic plates, or the idea of plate tectonics, is that Earth's lithosphere is broken into pieces and those pieces move relative to each other. We discussed the fact that there's three types of plate boundaries. Divergent, you should have already learned about if you watched the last lecture. So we have convergent and transform left for today. So if we talk about convergent boundaries involve the destruction of lithosphere at a subduction zone, which is a trench. So subduction zone is just another word that we use for a trench. But basically, if you have two tectonic plates and they're moving towards each other, what a subduction zone is where one plate goes underneath of the other one. So you have a trench here. You have two plates that are colliding. And then this area here is what we call a subduction zone. So this is where one tectonic plate is going underneath of another tectonic plate. So as it does so, this tectonic plate is destroyed. And the reason for that is because as it goes farther beneath the other tectonic plate, it gets warmer or hotter in temperature. And we discussed that as you go deeper beneath Earth's surface, it gets hotter. So what will happen is that once this rock, this oceanic floor or crust, is pushed far enough down into the mantle, it heats up, it melts, and it will turn into liquid rock or magma. So it will be destroyed at a subduction zone or at a trench. So at this location, you can get earthquakes that happen. You can also get volcanoes that will form. And usually a volcano will pop up on the tectonic plate that is not being subducted. Just to show you a location of where a majority of Earth's convergent plate boundaries are, most of them are located around the Ring of Fire, which is this zone in the Pacific Ocean. And every blue line that you see here is a trench. So this is a location where two tectonic plates are colliding and one is getting pushed underneath the other. So when we have two plates that collide, it can take three different scenarios. One, you can have an ocean that's colliding with another ocean. So you can have a situation where you have one oceanic plate. You can have a second oceanic plate. They are barreling towards each other, and one of them has to kind of lose out and lose this competition. So if you imagine this as a competition between an ocean and an ocean, one of them has to lose. And the loser is going to be the one that gets subducted or pushed down underneath of the other one. And usually that one is going to be older. So it might be many millions of years older, or it's more dense. So if it is dense, that basically means it's heavy. It's got a lot of weight to it. And things that are more dense, they will sink relative to things that are less dense. So in this diagram up here, the one that's the loser of this competition is this right side tectonic plate. It is getting shoved underneath of the one on the left side. So then again, it will melt, turn into magma, and that magma will erupt out of volcanoes. And what you'll see in this type of convergent plate boundary is that you'll get these volcanoes that pop up out of the ocean floor, basically due to the melting of one tectonic plate. So if you're watching the animation on the right side, you have a cool temperature ocean floor. It goes underneath of another ocean. It heats up. When it heats up, it produces liquid rock, magma. Magma rises, it erupts out of the volcano, as the animation was showing you. So what that looks like on the actual ocean floor, we have two tectonic plates. So we have this tectonic plate on the right side. We have the tectonic plate on the left side. The one on the right side is going underneath of the other tectonic plate that produces these volcanoes. And what you have is a volcano that comes out of the ocean floor. Then you'll get a gap of ocean in between that. And you'll get another island. Then you get a gap with water. And then another island that is a volcano. So that's typically what these will look like. Just to give you a couple examples of where you could find this, or one example of where you could find this around the globe. Up in Alaska, there is a chain of islands that comes off the coast of Alaska called the Aleutian Islands. And basically every red triangle that is on this diagram here is a volcano that is formed from two oceans colliding. So there's the Pacific Ocean, has a tectonic plate, and then north of that there's another tectonic plate. They're colliding, and one is getting pushed underneath of the other. So what the Aleutian Islands look like is that each island is a volcano. In many cases, there are snow-capped volcanoes. So there's a volcano, and there's some ocean in between that, and then another volcano. Same thing here. We got a volcano, we got the ocean in between, another volcano, ocean in between, and then another volcano. All right, again, just to show you where that is geographically on a map, here is Alaska and then Russia over here on the left side. What's happening here is that you have the collision of the Pacific plate and the North American plate, and then one is going underneath of the other. So you get volcanoes that will form. And then again, this map here is just showing you that there's more volcanoes. You will also get earthquakes. EQ is earthquakes. You are also getting earthquakes, thousands and thousands of earthquakes that occur at that type of plate boundary. So that was ocean to ocean collision. Let's say you have an ocean colliding with a continent. So you still have two tectonic plates, but now one is an ocean and one is a continent. So 100% of the time, the loser, if we call this a competition, the loser in this scenario is the ocean. Oceans are dense, oceans are heavy. So the fact that they are old, dense, and heavy means that the ocean loses out in this competition. And again, 100% of the time, it's not even a competition. The ocean's going to lose, and it goes underneath of a continent. The mechanism is the same here. We have a trench, we have a subduction zone, we have one plate going underneath of the other, and as it gets pushed deeper down into the mantle, it starts to melt, and that melt produces magma, liquid rock that rises up and produces volcanoes on the edge of a continent. Here's an example. So an example would be the Andes mountain range in South America. So you have the Nazca plate, and it is colliding with the South America plate. South America plate is a continent. Nazca plate is an ocean. So you have an ocean that is getting pushed underneath of a continent. Just to show you, you got oceanic crust. It's getting pushed underneath of continental crust at a subduction zone. And as it does so, it is melted and produce these volcanoes, the volcanic mountain range known as the Andes. Again, just to show you what I'm talking about, here's the South American plate, here's the Nazca plate. The Nazca plate is made of ocean, South American plate is made of continent. The ocean is going underneath of the South American plate, and as it does so, it has pushed up these Andes mountains, which are volcanic mountains that formed over millions of years. Just to give you examples of what that looks like, produces these very beautiful volcanic mountain ranges. The bottom one here is from Patagonia in the southern part of South America. So if you're having trouble visualizing it, here's an animation for you. We have a continent, we have the ocean, and we have the ocean going underneath of the continent. So as it does so, it heats up, it melts. That lava or magma will rise up to the surface, and then you get these volcanoes, the Andes Mountains, that will erupt on the coastline of South America. So in terms of features that you find there, if we're looking at the west coast of South America, we have deep and shallow earthquakes. So again, thousands and thousands of earthquakes that occur at that plate boundary. We also get lots of volcanoes. Basically, the entirety of the Andes Mountains range is just nothing but volcanoes. So our third type of convergent boundary, so we had two oceans colliding. We had one ocean colliding with a continent. Our third one here is two continents that are colliding. So this is called a continental convergent boundary. I know it's a mouthful, but basically you have two continents that are colliding. If we frame this again, just to use this to say it's a competition between two tectonic plates, there is no winner in this scenario. So nothing's losing, nothing is winning. Basically what happens when you have two continents that collide is that they just push together and then they move vertically. So they will form these mountains that are not volcanoes, but they're just regular old mountains made of rocks as they smush together. So as an example, continental crust on the left side, continental crust on the right side. These two tectonic plates are colliding, and what it does is it pushes up these mountains that form. Here's another animation just to show you. So we have two continents colliding. They're moving towards each other. And basically what they do is they kind of fuse together and then they get pushed up vertically to form mountain ranges. A couple examples would be the Appalachians. So the Appalachian Mountains, or Appalachians if you're from Massachusetts. I'm from the South, so I say it differently than you probably do. The Appalachians formed when Pangea was forming and the North American and the African plate collided. And that's basically what pushed up the mountains that we have here on the East Coast today. Another example is the Himalayas. So they're about 50 million years old. Where the Himalayas came from is when India, after Pangea split apart, India basically moved north and slammed into Asia. And as India slammed into Asia, it pushed up the Himalaya mountains. So obviously the largest and tallest mountain range on Earth was formed due to continents colliding in plate tectonics. Here's kind of a grainy animation of it, just showing you what happened when India collided with Eurasia and then pushed up the Himalayan mountains. All right, just some more pictures for you. In terms of features, so you don't get volcanoes here at these types of plate boundaries, but what you do get is that you get these high topographic variation. What I mean by that is that you have a lot of peaky areas or a lot of mountainous areas relative to sea level. You also get lots of earthquakes, so there's a tectonic plate boundary right here. You will get lots of earthquakes that occur as those tectonic plates are colliding as well. All right, there's a YouTube video that I have a link to, but it'll be in the quiz as well that you can watch, and it kind of shows you the mechanism of how volcanoes form in response to tectonic plate movement. So the last one that we need to talk about here is transform boundaries. So convergent, splitting apart, divergent splitting apart, convergent colliding. Transform, it's basically they just slide past each other. There's no vertical movement, so it's not either getting pushed up or dropping down. It's all just kind of a two-way traffic sliding past each other. So in a transform boundary, you don't really create anything. You don't create volcanoes, but you also don't destroy anything. So there's no volcanoes, there's no melting, there's nothing that happens in terms of that. The only thing that will really happen at a transform boundary is that you get large earthquakes that can occur. So here's an animation of a transform fault, two tectonic plates sliding in opposite directions of each other. And you can usually see the evidence of a transform boundary by looking at roads. So roads might get offset, or railroad tracks might move, or you might have a fence that moves as well. Our example here would be the San Andreas Fault. So the San Andreas Fault is in California. So one part or one side of the San Andreas Fault is going in one direction. The other side of the San Andreas Fault is going in the other direction. So you don't get volcanoes, as I said, but you can see this feature on land. It kind of just has this crumpled area as the two tectonic plates are sliding past each other. And we'll talk about this more when we talk about earthquakes next. So just to summarize everything, here's a good slide for you. This shows you divergent boundaries, mid-ocean ridges, where that material comes from. And then this shows you convergent boundaries. So you have a trench here. So it shows you how a trench happens and then what happens in a trench. So I just want to finish up by reiterating that plate tectonics in earth science is basically like evolution in biology. So it is kind of the underlying theme for understanding all of the other stuff that we'll talk about in this course. So without plate tectonics, we'd have a much harder time explaining earthquakes. We would have a much harder time explaining volcanoes, and we would also have a much harder time explaining rocks. So the next two sets of lectures are going to be the crux of that, looking at earthquakes and then looking at volcanoes.